I think it important that we spend some time reviewing these first few sections involving solving quadratic equations, because quite honestly, most people know how to solve the equations by any one of these four processes that I have listed here if they're told which method to use. But if you're not told which method to use and you're on your own, people tend to get a little bit confused. First off, factoring is always the easiest if an equation is factorable. It needs to be in standard form for that to occur. You can square root each side of the equation when you have a completed square, such as this x squared, but without any other x's in the equation. So this is clearly not going to be a method we're going to use on this problem. Completing the square and the quadratic formula both require that the equation be in standard form, which we can get for this problem. So what I want to do is start by doing this problem by factoring. I want to first set it equal to 0, x squared minus 8x is equal to 0, and then we can see very easily that we can factor out an x, have 8x minus 8 left equals 0, and our two solutions are going to be 0 and 8. Now let's save this same problem by completing the square. Now I want x squared minus 8x with a little blank in there. There's no constant to move to the right, but that's okay. We can cut the negative 8 in half to negative 4 and square it to 16, which we need to add to the other side of the equation also. The left side can be written as a completed square, x minus 4 squared equals 16. And because we've got that completed square on the left, we can square root each side. X minus 4 will be plus or minus 4. Technically that plus or minus comes from the absolute values that would be there if we had written them. And adding 4 to both sides, we're going to have 4 plus or minus 4, which you know if you add them you get 8, and if you subtract them you get 0. So we have the same solution set that we had up above. The third way we're going to solve this system is by using the quadratic formula. We've got x squared minus 8x equals 0, and so a is going to equal 1, b is going to equal negative 8, and there is no constant term, so c will equal 0. Now I'm going to begin by finding the value of the discriminant, b squared minus 4ac, which will be negative 8 squared minus 4 times 1 times 0. Well, that's 64 minus 0, which is 64. So we can continue on with the rest of our quadratic formula and say x is equal to negative b plus or minus the square root of 64 that we just found all over 2a. X will be negative b, well that's negative of a negative 8, which is 8, plus or minus 8 all over 2 times 1, which is 2. Now we've got that plus or minus we need to take care of. If we add 8 plus 8, we get 16 divided by 2, which is 8. And if we subtract 8 minus 8, we get 0 divided by 2, which is 0. So this is consistent, getting the same solution set all three ways. This next problem is reducible to quadratic. We can factor and have a y to the 1/3 at the beginning of each parentheses. And then the two numbers that multiply to 4 and add to 5 will be 1 and 4. So we will have y to the 1/3 equals negative 1, or y to the 1/3 equals negative 4. We can undo this cube root by cubing each side, and that will end up giving us negative 1 or negative 64. In this next problem, we do not see any x squareds yet, but after we do our distribution on each side, that'll become apparent. We will have 4x squared plus 12x on the left equals 12x minus 24 on the right. And we need to set this equal to 0 before we can determine what method we want to use. So we will have 4x squared. After we subtract this 12x off, it's gone. We'll have plus 24 equals 0. Now we have a choice here. I can either bring the 24 to the right and square root each side, or I can factor, which I want to do, and have x squared plus 6 equals 0. At that point, we have a couple of choices. We do know that we can ignore this 4 because it's a constant and it can be divided off of each side. You can either say, well, you got two choices. Some of you may say, you know, let's go x squared plus 6 equals 0. Subtract the 6 on each side to get negative 6 and get x equals plus or minus I root 6 that way. Personally, I would look at this and say, it's the sum of two kind of squares. I would factor it into x plus root 6I times x minus root 6I equals 0, and then get these same solutions. Now, how do I go about doing that type of factoring? Well, if that was x squared minus 9, I'd square root the 9. Well, it's a 6, so I'm square rooting the 6. You can't factor the sum of two squares because it's not considered real, but if you put an I at the end of each parenthesis, you can. And so you really have two approaches as ways to get to those two solutions.